with the help of the derivatives of sine and cosine, we can now differentiate the other four trigonometric functions: tangent, cotangent, secant and cosecant. And this is how it starts. And this is the reason. Since sin x and cos x are differentiable functions of x, and this happens at every real number x, that is why these algebraic combinations of sin x and cos x, for example tan x, which is sin x divided by cos x, secant x, which is the reciprocal of cos x, cot x, which is cos x divided by sin x, and cosecant x, which is the reciprocal of sin x, are all differentiable at those real numbers where they are defined. I mean, those are the values which make the denominators non-zero. At those places these functions are defined, and at those real numbers these functions will also be differentiable. Why? By the quotient rule. You see, before you go for the derivatives of these functions, you have to make sure that they are differentiable. So quotient rule takes care of that and will also help us actually find the derivatives. So let's see how. So we first differentiate the tangent function, and it's given as an example. Here we have to find dy dx if y equals tan x. So it is understood that x has to be a real number which is not any odd integer multiple of pi divided by 2, because at those points tan is undefined. So accordingly we started the solution. For any real number x which is not of that type, we have, you must write that here this n is an integer. N is coming from the set of integers, and then 2n plus 1 is any odd number. So x is not like that. So for any such x, if you differentiate y with respect to x, that means differentiating tan x, which is sin x divided by cos x. And so by the quotient rule, this is equal to this. So recall the quotient rule, you square the denominator. Then in the numerator you write the denominator first and then multiply that by the derivative of the numerator, minus. Then you put the numerator and then multiply it by the derivative of the denominator. So that way cos x times ddx of sin x minus sin x times ddx of cos x. Now recall these derivatives. The derivative of sin x is cos x. So here you get cos x times cos x minus sin x times the derivative of cos x is minus sin x. Don't forget this minus sign, okay. So you can immediately see that this minus and minus will become plus. So you are having cos square x plus sin square x in the numerator. That means you are having 1. So let's continue. So that way we have this, and so we are getting 1 divided by cos square x, which is secant square x. So that means the derivative of tan x is equal to secant square x. It will be a good idea to remember this, okay. Although you can quickly apply the quotient rule, and if you forget the formula by chance, you can derive it, but it will still take some time. So that's why it's a good idea to remember this. So let us now differentiate the other functions in the subsequent examples. Next, example 8. The function is secant x this time. However, we not only have to find the derivative, but we have to actually find the second derivative, y double prime. So we start just like the previous one, and here also, because secant x is 1 divided by cos x, we have to avoid the odd integer multiples of pi divided by 2. So accordingly, x is a real number which is not a real number of this type. So then obviously we just straight away start applying the quotient rule, and you can see that this time I haven't even mentioned that we are applying the quotient rule because it's obvious. And we will also not every time write things like this. This is not how we will start. We will push these things in the background, assuming that they are there, and whoever is reading this or going through this already knows. Okay, so ddx of secant x is ddx of 1 divided by cos x. So if we apply the quotient rule, you square the denominator, so it becomes cos square x, then denominator times the derivative of the numerator, which in this case is 1, minus the numerator, that means 1, times the derivative of the denominator, which is cos x. So what shall we get from this? So we get this. ddx of 1 is 0 because 1 is constant, so this term will vanish, and minus 1 times ddx of cos x. ddx of cos x is minus sin x, so minus sin x. So that way we get 0 plus sin x. So sin x divided by cos square x, and you can then write this as this product of these two things, 1 divided by cos x and sin x divided by cos x. This first thing, first ratio is secant x and the second ratio is tan x. So that way you see that the derivative of secant x is secant x times tan x. But the derivative of tan x is secant square x. And it of course doesn't end here because we have to find the second derivative also. And you can already see that you can apply the product rule to do that because this is your first derivative. And after applying the product rule, you are going to need the derivatives of secant x as well as tan x, which we now know. So let's do that. So next we have the second derivative, which is the derivative of the original function, which is secant x. So just now we have found that this is secant x times tan x. So we then apply the product rule for differentiation. Secant x times the derivative of tan x plus tan x times the derivative of secant x. This derivative is secant square x. So secant x times secant square x. And this second derivative, I mean the second one, okay, not, the second derivative, this one is secant x times tan x. So tan x times secant x times tan x. So that means we are getting secant cube x plus secant x times tan square x. Let's write that. So secant cube x plus secant x times tan square x. So that's the second derivative. And in this next example, we are going to see the derivatives of cot x, cotangent function, and there is part B also where we have the cosecant function. But it's not just that, we actually have to find this. In fact, the way this example appears in the text just straight away calculates the derivative. We are, however, not going to do that. We will first separately calculate this cot x because it's going to be a formula that we are going to need. So we are going to take it apart from this thing and then we will apply that here to find this. So let's do that. So accordingly we start the solution straight away by going for the derivative of cot x. Note that because the function cot x is being considered and sin x is in the denominator, so we have to avoid those real numbers where sin x vanishes, namely the integer multiples of pi. But we haven't written that because it's understood, it's there in the background. So we apply the quotient rule as usual. So first we square the denominator sin square x, and in the numerator we first write the denominator sin x times the derivative of the numerator ddx of cos x minus the numerator, that is cos x, times the derivative of the denominator, which is sin x, ddx of sin x. So you can now see that we have sin x times minus sin x because ddx of cos x is minus sin x, minus cos x times cos x, ddx of sin x is cos x, there is no minus sign. So what are we going to get from this? Now also we will get sin square x plus cos square x, but with a minus sign. That means now we are having minus 1 in the numerator and the denominator is sin square x. So what shall we get from that? We get that means we are having minus cosecant square x, because 1 divided by sine square x is cosec square x. You may remember that I made one remark when discussing about the derivative, actually finding the derivative of cos x. We calculated and we found that the derivative of cos x is minus sin x. And what did we find today? The derivative of secant x is, tan x is secant square x. And the derivative of secant x is secant x times tan x. But now we are finding that the derivative of cot x is minus cosecant square x. Do you remember that I said that these functions with a co in front, they are going to have a negative sign in their derivatives. We see that happening here. ddx of cos x is minus sin x. ddx of cot x is minus cosecant square x. Okay. And if we use that to actually calculate the thing that we were supposed to calculate, then differentiating 3x, of course, we already know that it will be 3, and the ddx of this is minus cosecant square x. So that is part A. Now let's see what we have in part B. So in part B, we have to find the derivative of this ratio 2 divided by sin x. Now you can directly, of course, apply the quotient rule, but we will do it slightly differently, because we notice that 1 divided by sin x is cosecant x. So if we calculate the derivative of cosecant x separately, we are going to need it afterwards, because every now and then this cosec function will appear and we may have to differentiate it. So that is why we are going to treat this function as 2 times cosecant x. So if you want to differentiate that, first of all, by the constant multiple rule, 2 will go outside. So that means you just have to find out the derivative of cosecant x and multiply it by 2. So that way you will have a formula for cosec x derivative, as well as you will find this. So let's do it. Accordingly, we start the solution by noting that 2 divided by sin x is 2 times cosecant x, and then we go for the derivative of cosecant x only, leaving out 2. So of course this is 1 divided by sin x, so again we apply the quotient rule. So we square the denominator, usual stuff, and then write the denominator first, multiply it by the derivative of the numerator minus the numerator times the derivative of the denominator. Again, just like before, this becomes 0, and ddx of sin x is cos x. So that way we get minus cos x divided by sin square x, which we can then write like this: minus 1 divided by sin x times cos x divided by sin x. This ratio is cosecant x and this ratio is cot x. So here also you see that observation is true in fact. This is also a function which starts with co. Co means in the short notation we write CSC, but there is a longer notation which has, I think it has fallen out of use. No one really writes cosec like COSEC. It used to be written like that before. So there is a co and you are getting a minus sign here. So this observation may help you remember these formulas. But in any case, if you forget, then you can quickly find it out. It won't take much time. So let's complete the solution. So finally, of course, we actually had to calculate this derivative of 2 divided by sin x. So that is the derivative of 2 cosecant x, 2 times derivative of cosecant x, which is this. So this is your final answer. And finally, let us summarize and write the 4 derivatives we found today, so that we can see them in one place. So these are the 4 derivatives we found today. ddx of tan x is secant square x, ddx of secant x is secant x times tan x, ddx of cot x is minus cosecant square x, and ddx of cosecant x is minus cosecant x times cot x. And we already know those first two. ddx of sin x is cos x, and ddx of cos x is minus sin x.